Okay, in this lesson we will learn how to find the GCF, or greatest common factor, of monomials. Suppose we had to find the greatest common factor of 16 and 24. If you recall from earlier grades, the greatest common factor of 16 and 24 is the largest number that divides both, or the largest number that divides both. Okay, so if you recall, one of the ways to do this is to break both of these numbers down into their prime factors. So notice I could write 16 as 2 times 2 times 2 times 2, which is 2 to the power 4, and 24 I can write as 2 times 2 times 2 times 3, which is 2 to the power 3 times 3. Now, if I'm interested in the greatest common factor of both of these numbers, I'm looking for the largest number that divides both. Well, notice at the very least they both have in common one factor of 2. In fact, they have in common not only one, but they have 2 and 3 factors of 2 in common. Okay, so let me draw here for you. They have not only one 2 in common, but they have another 2 in common and yet another 2 in common, for a total of 3 factors of 2 in common. Right? So notice that since I have 2 times 2 times 2 in common, both of them, in fact that's the greatest number that they have in common. The greatest common factor of these two numbers would be 2 to the third power, or 8. This notation here just means the greatest common factor of 16 and 24 is 2 to the third power, or 8, since that's the largest number that divides both of these. Now suppose I had to find the greatest common factor of two monomials. It's not very different. In fact, it's essentially the same thing as finding the greatest common factor of two numbers. Okay, so the first technique we're going to use is, let's break the first monomial down into its prime factors. Okay, so let me start with the coefficient. The prime factorization of the coefficient is 2 times 2 times 2, whereas the factorization of the variable part is y times y, since I have y squared here. You can do the same thing for 4y to the fourth power. Notice that 4 has 2 factors of 2, and y to the power 4 has 4 factors of y. So in common here, notice that they have not only one factor of 2, but 2 factors of 2 in common. Not only that, but they have not one factor of y in common, but 2 factors of y in common. So altogether, the greatest common factor would be 2 times 2 times y, which is the same thing as 4 times y squared. Okay. Once again, this is read as the greatest common factor of 8y squared and 4y to the fourth power is 2 times 2 times y times y. Another way we can look at this is in the following way. Let's just write the prime factorization of 8 and leave the variable part alone. So 8 can be factored as 2 times 2 times 2, and I'm going to leave the variable part alone. Do the same thing with 4y to the fourth power. Leave the variable part alone. Okay, so notice here that, once again, these two monomials have 2 factors of 2 in common. Not only that, but y squared divides the first monomial and it divides the second monomial, because y squared is a factor of y to the fourth power. Okay, so this is just another way of thinking about it. Okay, so the greatest common factor of these two monomials, once again, will be the greatest common factor of the constant times the lowest power that you see on the variable. Okay? Because the lowest power of the variable that you see will divide both of these monomials. The lowest power of y we see is y squared. Notice that y squared divides y4. However, conversely, it's not true. Y to the fourth power does not divide y squared. So the greatest common factor, if you're just looking at the variable parts, would be y squared. So the greatest common factor, once again, of both monomials is 2 times 2 times y squared, which is 4y squared. Another way of looking at this, and probably the more efficient way, is whenever you're finding the GCF of monomials, what you do is you find the GCF of the coefficients first. So my coefficients are 8 and 4. The greatest common factor of 8 and 4 is 4. And then you find the greatest common factor of each variable part. So notice that the greatest common factor of y squared and y to the fourth power is y squared, the lowest power of y that I see. So therefore, the greatest common factor of both monomials would be 4 times y squared. Okay, so now we're going to switch to finding the GCF, or greatest common factor, of 3 monomials instead of 2. The process is exactly the same. What I want to do is I want to find the greatest common factor of the coefficients first. Okay, so let's just look at the coefficients here. Right away I see that 3 divides all 3 of these. Now, is there any number that's bigger than 3 that divides all 3 of these coefficients, 9, 6, and 12? It doesn't look like it. Okay, because 9 I could write as 3 times 3, 6 I can write as 3 times 2, so already the greatest common factor of these two is 3. Okay, and I could write 12 as 3 times 4, so the greatest common factor of 9, 6, and 12 is 3. Okay. Next thing I look at is my variable a. Notice that only the first 2 monomials involve any powers of a, while the third one does not. So in other words, a divides the first monomial, a divides the second monomial. So far, if we don't even look at the third monomial yet, it looks like the greatest common factor in terms of a here would be a to the power 1, because a divides both of these. But if you look over here to the third one, a does not divide 12b. There's no power of a here. So a is not going to be in the GCF. Okay. And then I look at my last variable, b. Well, b to the power 1 divides this monomial, b goes into this, and b goes into this. Is that the greatest power of b that divides all 3 monomials? Yes, it is indeed. It's the smallest, or b is the greatest common factor of b, b to the power 3, and b squared. Okay, so the GCF of b squared, b to the power 3, and b is b itself. Notice that that's the lowest power of b that I see here. Okay, so the greatest common factor of these 3 monomials then will just be the product of the GCFs of the coefficient and the variable parts. So that will just be 3 times b. Okay, so now we're going to look at GCFs of expressions involving binomials. Okay, so take a look at this expression here. Notice that I can factor it as 3 times x plus 5 times x plus 5. So these are the 3 factors. Okay. Now, x and 5 are not factors of this expression. That's a common mistake that students make, is to say that x is a factor of this expression when it's not, because x does not divide this expression here, nor does 5. Okay, so this is important when you're finding the GCF of expressions involving binomials, is to understand what are factors and what are not factors. Okay, notice that 3 is a factor, x plus 5 is a factor, of course. Okay, but x and 5 are not factors, because there's no number that I can multiply x by to get this expression, nor is there a number I can multiply 5 by to get this expression either. So those are not factors of this. The only factors of 3 times x plus 5 squared are 3 and x plus 5. Okay, so let's find the GCF of these 2 expressions that involve binomial factors this time. So once again, I'm looking for the greatest common factor of these 2 expressions. Alright, so the first thing I start with is find the GCF of the coefficients. Notice that the biggest number that divides both of these is 2. So the GCF of 6 and 8 is 2. Okay, and then I look at the largest factor of the binomial part that divides both, and notice that x minus 2 squared is a factor of this, and x minus 2 squared is also a factor of this. Okay, because x minus 2 to the fourth power is just x minus 2 times x minus 2 times x minus 2 times x minus 2. So there's 4 x minus 2's here as factors, whereas there's 2 here. So the greatest common factor of these two parts, of these binomial parts, is x minus 2 squared. Okay, so there's that. So now the greatest common factor of both expressions is just going to be the product of these two GCFs, which will be 2 times x minus 2, that quantity, squared. Okay, so the essential question that we answer today is, how can you find the GCF of monomials? So for monomials whose factors are numerical coefficients and variables, the first thing you do is you find the GCF of the coefficients, and then you find the GCF of the common variable factors, and you take the smallest power of the common variable factors, and your GCF will be the product of those two GCFs.